Hello everyone. Now we are going to discuss a topic called data types. Data types enable the user to reserve required amount of memory for the variables in a program. Whenever a user writes a program, he will be making use of some of the variables in his program. So for all the variables that the user makes use of, we need to reserve a desirable amount of memory. In order to reserve the required amount of memory for the variables of the user, we need to take the help of data types. So let us consider user wants to create a variable to store the roll number of a student. So for that, a data type is there called as integer. Okay, 2 bytes of memory is sufficient to store the roll number of a student in general. So integer is the data type that is available in C that we can make use of to reserve 2 bytes of memory. So we'll write integer the variable name, so the system will understand that the variable name is like this and the 2 bytes of memory has to be allocated for the variable. And as it is already discussed in features, I have said that C is a typed language because it supports data type system. Data types are very much useful. As we go through the discussion, we'll be able to understand how important this concept is. Generally, the data type of a variable defines two very important things. The first one is size of the variable. That is nothing but the amount of memory that will be allocated for the variable. And the second thing is type of the data stored in the variable. Means what kind of data, whether it is a character or integer or a floating value which is going to be stored in the variable. So these two things are sufficiently enough to define a variable. The data types available in C are divided into two parts. The first one is default data types and the second one is user defined type, that is called as UDT, which is something that we'll see at a later part of our discussion. At first we'll focus on default data types. There are a set of 6 default data types in C, like character, integer, long, float, double, long double. Let us see the functionality of each and every data type. If we see character, it is defined as char. It reserves 1 byte of memory and it is used to store characters and small integers. Though the name is character, but still it can be used to store integers. Next one is integer. If we want to store some big integers, then we can make use of this data type. It reserves 2 bytes of memory. And long reserves 4 bytes of memory. It can be used to store large integers. And coming to float, it reserves 4 bytes of memory and it can be used to store small floating values, that is small decimal values. And double will reserve 8 bytes of memory. It can be used to store big floats. And long double can be used to store big numbers, that may be integers or floats, preferably floats. Okay, it reserves 10 bytes of memory. We usually don't find a variable in need of 10 bytes of memory to store a single value in practice. So in uh, some advanced programming languages like what we say Java, etc., we don't have a long double data type. We have removed this long double from the data type system as it is not used too much. And of course, the absence of long double can be countered by some advanced features of these programming languages, so we don't need to bother about it. So as we have seen the 6 data types, out of these 6, character, integer and the long are integer type and float, double, long double are floating type. In the sense they will be used to store floating values. Yeah, that is about data types. Now we shall see something called as identifiers. So whenever the user wants to create a variable, constant or a function or something which is user defined, in order for that to be identifiable by the user, he has to assign a name to that. Out of so many library functions, if the user wants to distinguish his own function, his own user defined function, then that can be done only by assigning a name. Similarly, out of many variables, the distinction can be done only by defining the name of the variable. Okay, so the names that are assigned to variables, constants, functions, etc. are nothing but called as identifiers. So identifiers enable the user to quickly recognize and distinguish the variables in a program. When we assign a name to variable, constant, or something like that, means when we make some identifiers, when we define some identifiers, we need to follow certain rules. Like the identifier name can have only alphanumeric characters, that is A to G, that may be lowercase or uppercase, numbers like 0 to 9, and underscore. It cannot contain any special characters like semicolon, period, white spaces, slash or comma, etc. Though the identifier name can contain numbers, but the first character of an identifier can only be an alphabet, that is A to G, that may be lowercase or uppercase, or it can start with underscore. Identifiers are also case sensitive in C. Not only identifiers, whatever the thing that is defined in C, that may be default or user defined, all the things are case sensitive in C. Why? Because C itself is a case sensitive language. So as it treats the lowercase and uppercase alphabets differently, we need to take care of that. For example, if you consider NAME in lowercase and NAME in uppercase, these two, though the spelling of that identifier is same for us, but for the system these two identifiers are different. Why? Because C is a case sensitive language. Keywords are some these are what reserve words, so we cannot make use of keywords as identifiers. I mean to say, we have a keyword called as long, so we cannot define an identifier or a variable with the name of long. And apart from all this, two identifiers cannot share a common name. If you want to create two variables, if you want to create many variables, all the variables should have a name of their own which is different from the other. Why? Because two variables cannot share the same name. Okay, then let us see the creation of variables and how the memory is allocated and how the memory mapping is done. Okay, memory mapping representation is nothing but showing how the memory is allocated for the variables. So for this, let us see some examples. Like we'll create x, a, b, c, d, 5 variables here. All are of different types. X is an integer, a, b are long, c is a float, d is a character. So the syntax is write the data type, then after a space put a space, after that variable name. This variable name is what called as identifier name. Okay, this x, a, b, c, d, all these are identifiers. So for x, what happens is, as integer reserves 2 bytes of memory, for x 2 bytes of memory will be reserved. It is already told that memory address is always a hexadecimal number, but it will be difficult for the user to understand. So that is the reason why we are considering the address to be a normal number, that is the decimal number. So here we have taken the example as 3001 to 3002, that which constitutes 2 bytes of memory for the variable x, and the value of x is nothing. We have not assigned any value to x, but still by default there will be some value in x that is not understood by the programmer or the user. It is some undesirable value. This value is not meaningful for the user, but it will be meaningful for the system. Maybe some software has allocated some memory there, and that software is closed now. So whatever the content of that software was, it is there in the memory, and in that memory itself we have allocated our variable. Some particular portion of the memory has been allocated for a variable, so the data which was residing in that memory will now be present in x. So though it is present in x, it's an undesirable value. We cannot we can make use of that value, but it is of no use. So that kind of undesirable, unrequired value that will be there in the variable by default is called as the garbage value. It is of no use. In the next statement, if you see, we have created a variable long a is equal to 10. So here what happens is, there is another variable created. So a and b, two long variables will be created having 4 bytes of memory each. For A it is from 3010 to 3013. For B it is 4001 to 4004. In A, while creating the variable itself, we have assigned some value, that is 10. This kind of assignment while creating the variable is called as initialization. Initialization of a variable means assigning a value to the variable as soon as it gets created. So B is not initialized, X is not initialized, but A is initialized. Similarly, if you see the next statement, C is also initialized and D is not initialized. So in A, the content will not be garbage anymore. The content will be 10. But in B, what happens? The content will be garbage. If you see the next statement, float C is written. As it is a floating variable, so for this float variable, 4 bytes of memory starting from 4050 to 4053 will be allocated, and the content will be as assigned by the statement, that is 10.1. For D, again it's a character variable, so only 1 byte will be allocated. Yeah, one more thing that you might have noticed here, the address of these memory blocks. First one is 3001 to 2. Second one, you might think that it is from 3003, and you will get a doubt why it is from 3010. See, in RAM, every time some process will be getting loaded. So we cannot say that for all the variables the same block of memory or the consecutive block of memory will be allocated. There is no such rule like the consecutive blocks of memory have to be allocated for individual variable. When the C runtime system tries to allocate memory for a variable, at that moment of time, whatever the memory is vacant, whatever the memory is free, that will be allocated to the variable. So it may be in a consecutive way, it may not be in a consecutive way. We cannot give any assurance on that. But somewhere, whenever a variable is created, somewhere for that variable a memory will be allocated with a specified address. So here is the note. Address of a variable is a hexadecimal number, but for easy understanding we consider it as a decimal number without changing the identity and the meaning of the concept. Okay, the concept's meaning will not be changed. It's just to make the user able to understand what the address is, how the address operates. Yes, we need to make note of some other thing that is related to garbage value, as it is written here. If a variable is created without assigning a value to it, that means if a variable is not initialized, then the memory allocated to that variable will contain a value, an unrequired and undesirable value. By default it is getting stored, it will be there, it is called as garbage value. This value is of no use for the programmer or the user. And next one is a value can also be assigned to the variable at the time of its creation, like long A is equal to 10, the example that which we have seen. In this case the variable won't be containing any garbage value, rather it contains the user defined value which is 10. This way of assigning the value to a variable at the time of defining the variable, at the time of creation of the variable, is called as initialization of the variable. Thank you.